Okay, so in this video, we're going to answer this first EQ. Well, we're going to answer two EQs because this first one's pretty simple to answer. And then there will be another video after this one, obviously. This video is for day 7 of Unit 4 in geometry. Now we're obviously talking about pyramids. Um, so, first EQ, well, what is a pyramid? So, a pyramid is, to put it simply, if I had to put it simply, like in a literal sense, it is we'll just call it a 3D figure. Okay, it's a 3D figure, aka a polyhedron, such that it has a polygonal base with polygonal lateral faces. Right, that converge at an apex. We'll just say which converge. Ran out of room. At an apex. Okay, so that said, these pyramids all converge, their lateral faces, rather, all converge at an apex, right? That is directly perpendicular to the centroid of its base, right? And for all intents and purposes in my class, pyramids are always going to be regular pyramids. Okay. And what this basically means is that the base is always a regular polygon. Okay, so for fear of copyright infringement, I'm not going to click on the link that you see right there for Math is Fun to show you. I'm going to include that link in the description of this video. Um, but there's not only regular pyramids, there's also irregular pyramids. And if you're curious about what the difference there is, feel free to click the link and kind of play around on that site. This website, Math is Fun, is freaking awesome. So I really encourage you to click that link in the description and just learn a little bit more about pyramids. But for the sake of simplicity, we're only going to deal with regular pyramids and not irregular. So all that means is on regular pyramids, the apex, first of all, the apex is always perpendicular. It's always perpendicular to the centroid of the base, right? And this other part that I just said a second ago is always true. Okay, so there is such a thing as right oblique and just straight up irregular pyramids, right? And like I said, if you want to look into that, click that link in the description for Math is Fun. Like I said, awesome website, all kinds of cool stuff there. Okay, so EQ2, formula for calculating the surface area of a pyramid. Well, you don't really need a formula because you can tell with common sense, right? Any pyramid, if you wanted to find its surface area, well, just calculate the area of its base, right? So if I say surface area of a pyramid, if I can spell, is going to be equal to area of the base plus the area of all of its lateral faces, right? In this case, this is a square pyramid, so it's going to have 4 lateral faces, right? So simple enough here, right? So that's all we would say. So we would say plus n lateral faces, right? That's the number of lateral faces. Okay, times the area of each lateral face. And let me write that better, more like a subscript. So that's the area of each, that's important, each lateral face. Okay, and because we're limiting ourselves in this class to regular pyramids, right, this is really simple. Okay, that's the reason we can do that right there. So this first example here, simple enough. Okay, so let's go ahead and figure this stuff out. So area of the base, right? Well, duh, we can tell the area of the base is the area of a square. So that's 10 by 10 if we look at it purely in 2D, right? So 10 by 10, that means we're at 100 square meters, right? And I don't need to put that if I'm just doing the arithmetic. Okay. And then, of course, we're going to add to that the area of each lateral face. I'll use orange. Okay. So these faces all look the same. They are all a equilateral triangle, right? 10, 10, right? But this is a little bit tricky because 10 is not the height. We know the base, right? The area for a triangle is base times height divided by 2. Well, we need the height. And we can do little basic baby trig to do this. So 5, height is unknown. We're just going to call that h of f, height of the face, right? Now, we need to know this angle. Well, we're given this angle right here, right? Because this is a regular pyramid, all the faces are the same. So that means this is also pi over 3. So I can easily just use tangent. So I can say tangent pi over 3 is equal to opposite over adjacent, cross multiply, and we get that 5 times the tangent of pi over 3 is going to be equal to the height of our face, right? And we know that that's going to be 5 square root of 3, which is approximately, handy dandy calculator, 5 square root of 3. It's approximately 8.66. And if you're bad with remembering these kind of things, you can just do it this way. You can just enter this in. What is this thing doing, bro? Get out of there. Oh my goodness, technology. Okay. Pi divided by 3. Oh, cool. I like how it listened to none of those commands. Okay, but anyway, we see that we get the exact same thing. Okay, so 8.66, and that is in meters. So that's the height of each face, right? Okay, so base times height divided by 2. So let's go ahead and do that. So control divide. Base is 10 times height, which was 5 square root of 3, all over 2. Okay, and we get 43.30. So that's the area of each face. Right, so about 43.30. Right, and then the number of lateral faces, well, duh. If it's a square pyramid, we know that there's 4 faces, right? So all we need to do is add this all up, and we will no doubt get our answer. So let's go ahead and do that. So we have 100 plus 4 times, and I'll copy and paste my ugly 40.3013. And there we have it, our surface area for this particular pyramid. I already forgot what it was. 273.21. And that, of course, if we're in meters, that, of course, is meters squared. Okay, so utilization of this formula, utilization of surface area in general, like I said in the previous lesson, is very simple. Okay, it's a lot like perimeter, right? So if you have any questions over how to do any of this with pyramids, obviously shoot me an email or come find me. That does it for this video. Goodbye.